All right, so welcome back. Today we're going to be starting Chapter 2. And Chapter 2 is all about what we can do with different figures, whether they're the same figures, if they're similar figures. But in 2.1, the first section of Chapter 2, we need to have a good understanding of congruency. So we're going to be going through a lesson today all about congruency and how we can tell if two shapes are congruent to one another. So again, the essential question is, how can you identify congruent shapes? Remember, think back to congruency. Congruency means that they're the same. Congruent shapes mean that they are the exact same, just with like a different name to it. So you could have like triangle ABC and triangle DEF. Those could be the same shapes, but they're going to have a different name to it. You can think of identical twins, right? They have the same DNA, they have the same mindset, whatever. They look the same, but they have different names, right? One could be like Mike and John, right? Or Susan and Sally. They look the same, but they have different names to it. That's congruency in a nutshell. So, first 4 questions. Tell whether these triangles are congruent or not congruent. Okay, so just visually look through. Do you think that number 1, those 2 triangles are congruent? No way, Jose. They're not the same size. What about number 2? Are those 2 triangles congruent? Nope, not really. What about in number 3? Are those 2 triangles congruent? Remember, are they the same? No way. But what about number 4? Are they the same? Well, you might initially say no, because they're not facing the same direction. But if I just rotated it, you would see that these 2 are actually going to be the same. They're just not facing the same direction, and that's okay. But congruency is all about, are they the same values? So we have a couple key ideas that I want to go through real quick. So take a minute, jot down the notes, and then resume when you're ready to listen to me explaining it. Okay, so this key idea is all about congruent figures. I'm just going to read it first. Figures that have the same size and the same shape are called congruent figures. The triangles below are congruent. So over on the left, we have triangle ABC. Over on the right, we have triangle DEF. And they're saying that these 2 triangles are congruent. In order for that to happen, there's 2 aspects of it that have to occur. They have to have what's called corresponding angles, and they have to have what's called corresponding sides. So a corresponding, again, think back to our angle relationships, means they're in the same general location, right? So if we're looking at corresponding angles, it's pointing to angle B and pointing to angle E. Those are going to be corresponding angles, and they help us out here because they're color-coded. Notice how both B and E are green. That means they have the same value. You also are going to see that symbol underneath it. See how that has one like arc to it? Well, that says angle B is congruent to angle E. If I want to go and say, well, I know angle A and angle D are also congruent, I can use that same symbol. I can go 1, but I'm going to use 2 here because I want to differentiate between the 1 arc. And likewise, they're saying C and F are corresponding and congruent because they're both in red. So I can do 1, 2, and 3. 1, 2, and 3. Notice how they're the same value. Okay, you can see it within colors. You will also see it within the angle notation. So like the mini arcs. Notice how B, A, and C, all 3 of them have a different number of arcs to it because they're not congruent to each other. They're congruent to the other triangle. Likewise, we have what's called corresponding sides. Let me just erase this here. So corresponding sides, looking down here now, says that matching sides are going to be congruent. So you can tell that they're also color-coded. Well, AC is a green segment, DF is a green segment. So they're corresponding. They're going to be congruent. You also can see this notation, a line on it that says, hey, AC and DF are the same value. You also see BC and EF are blue, so they're going to be corresponding. And if they're congruent, they have the same length. So we can also use a double dash. Notice how I'm using 2 dashes on BC and EF because I used 1 on AC and DF. You got to differentiate between it. And likewise, AB and DE are both red, so they're corresponding. And if we're saying these triangles are congruent, then they're going to have the same length. So I can go 1, 2, 3. 1, 2, 3. That's what's going to help us tell what is congruent to each other. So AB is congruent to DE. They're both red, but they also have 3 dashes. BC is congruent to EF. They're both blue, but they have 2 dashes. And AC and DF are both green, but they have 1 dash. So there's a lot of different ways we can use to help differentiate and say, hey, this is congruent to that. This is congruent to that. Typically, we're going to see the arcs and the dashes. Arcs are for your angles, dashes are for your sides, okay? And we're going to get involved within that too. First off, great job, folks. Keep it up. Here we go. So in this example, it says the figures are congruent. Name the corresponding angles and the corresponding sides. So I look here, I have a 4-sided shape, okay? So I have 2 different quadrilaterals. We talked about triangles before, but the same topic here can go for any figure. So if I have ABCD and WXYZ, we know that these are going to be congruent to each other. But we want to say, hey, what are the corresponding angles and corresponding sides? So let's go through first. It says the corresponding angles. So I can say that A and W are corresponding. A and W. Notice how they both have 1 arc. I can say B and X, so 1, 2, 1, 2. I can say C and Y, 1, 2, 3, 1, 2, 3. I can say D and Z, 1, 2, 3, 4. 1, 2, 3, 4. Notice how they have a different number of arcs because we don't know any relationship inside that figure. We only know that it's congruent to the other figure. Okay? And for the sides, here's where it gets tricky. And a lot of students get stumped up here, but I know you won't because you're going to be listening, of course. Order is important. So notice that if I am talking about segment AB, if I'm talking about this segment right here, segment AB, what's the corresponding segment to AB? WX. Notice how A goes to W and B goes to X. That's shown right here. A goes to W, B goes to X. The order is important. So when we say AB and WX, oh man, I messed up, didn't I? Nope. Haha, I got it. Oop. No! Ah! There we go. Come on. Hey. There we go. I'm figuring this tech stuff out. So when I say sides AB and WX, that's right there. Or I can say BA and XW. Notice how the order is important. A goes to W, B goes to X. B goes to X, A goes to W. Okay? And we can see that a lot easier when we list out the angles first. Okay? We also can say that BC and XY. I'm putting 2 dashes there. Or CB and YX. We have CD and YZ. Or DC and ZY. And then we have DA and ZW. Or AD and WZ. Awesome. Let's keep it going. So in here, I want you to try it out on your own. It says the figures are congruent. Name the corresponding angles and the corresponding sides. So jot down the two figures exactly the way they are and try and figure out the corresponding angles and corresponding sides. Now, the only difference here is that they're not facing the same direction. So in your mind, you kind of got to look at it and see, okay, where would it be if they were facing the same direction? All right, it's gonna be a little bit different than before, but I know you can do it. You got this. All right, so if you're listening, that means that you have tried out the example here, and here are the answers. All right, sweet, nice job. Here we go. So another key idea. Before we talked about, hey, I know these two figures are congruent. What can I deduce from that? In this idea, it's a little bit different. We're saying, okay, what information do I know about the shapes? Can I conclude they are congruent from that information? So we're working a little bit backwards here. So the key idea here says two figures are congruent when corresponding angles and corresponding sides are congruent. Triangle ABC is congruent to triangle DEF. So again, notice how they color code everything. Okay, they have the arcs on the inside. So angle B has one arc, angle E has one arc. Angle C has two arcs, angle F has two arcs. Angle A has three arcs, angle D has three arcs. Okay, and notice how A and D have the same number of arcs, they're in the same order. So angle A and D are the first ones. B and E have one together. They have the same amount. They're in the same order. They're the second letters. Likewise, C and F have the same number of arcs. They're in the same order within here. Order is important. Okay, order is very important. Awesome, sweet. Here we go. Let's put it in here. So which square is congruent to square A? So we're talking about square A right here. It says which square is congruent to square A? So we now need to think about, okay, do they have congruent angles? Do they have congruent sides? So let's look at square B. Do they have congruent angles? Yeah, they're both square, so they all have 90-degree angles. That's awesome. Do they have the same congruent sides? Not quite, because square A has a side length of 8. Square B has a side length of 9. So they're not going to be congruent together. Let's just check square C. Square C seems to be turned a little bit, but that's okay because it doesn't change its shape. It just changes the way we're looking at it. Do they have the same angles? Yeah, it's a square. They all have 90-degree angles. And do they have the same side length of 8 and 8? Yes, we do. So we have congruent squares. So square C is going to be congruent to square A. Awesome. In this example, it says trapezoids ABCD and JKLM are congruent. What is the length of side JM and what is the perimeter of JKLM? So pause the video, try these two questions out the best you can. I know you can do it, and then resume when you want to hear the answers. Okay, so we know that these two trapezoids are congruent. So AB is going to be congruent to JK. BC is going to be congruent to KL. CD is going to be congruent to LM. And we know AD is going to be congruent to JM. So if we know that AD is 10 feet, well then JM is also 10 feet. And we can fill in our information. Well, we know JK will be 8. We know KL will be 6. LM will be 8. JM will be 10. And now to find perimeter, we add them all up. So we have 8 plus 6 plus 8 plus 10, 14 plus 18, and we get 32 feet. Now, is this perimeter going to be the same as ABCD? Yes, definitely, because these two shapes are congruent to each other. So 32 feet is the perimeter of JKLM, and it's also the perimeter of ABCD because these two shapes are congruent. All right, folks, great job today. You're doing so well with this. We're so proud of you. If you have any questions, please reach out.